Hello, I'm back for the second part of the lab, which is a lot different for people that don't have the lab kits than it is for people who do. So thanks for watching. This is the video for people with no lab kits. All right, let's get started. Part 2 of the lab starts off with 2 preliminary questions. So I'd like you actually to pause me right now and answer those at this time. Okay, you might be sad, like, she didn't give me the answers. Well, no, I kind of want you to think about it. Okay, so here we go. I posted a file for you that says, like, Introduction to Entropy, Spring 21 dots. You'll definitely want to open that version of this up because I made these dots for you that you can move around, and hopefully it works. If it doesn't work for you, what you'll want to do at this time is draw your own version of this grid. Do you see this grid here? It's like 2 solids, and each solid has 2 rows and 3 columns. So you'll want to draw your own version of that grid, and then also cut out little, it doesn't matter if they're circles, squares, and number them 1 through 8. Okay, so however you decide to manage this, go for it. So why don't we pause now, give you time if you're drawing this and making your own dots to do it. Okay, so you've got dots, you can move them, right? I don't know why mine is moving so crazy. Oh my gosh, why did that happen? Okay, oh, little mini heart attack there. You have dots, you can move them around. Okay, the first thing we're going to do is set our dots up in an initial state. And we're going to distribute them as described here. I've messed this up a few times already, so this is really hard to read, but here's what we're going to do. 6 of your chips are going to be in solid A. So I'm just going to move. So I have 6 chips in solid A. Got it. 2 chips in solid B. No problem. Okay, then in solid A, we're going to make sure 2 cells have 2 chips. Okay. Let's move you there. Okay. 2 have 1 chip and 2 have 0 chips. And then these other last 2 chips are singly into solid B. Okay. So what I'd like you to do right now is find your own version. Don't copy mine. That's boring. Okay. And so arrange them something like this. Go ahead and pause and do that now. All right, next, we are going to go over to the online dice roller. And what I want you to do is to click in that online dice roller Google search box and press enter or refresh your page so that you end up with 1 6-sided die, so like the initial setup. Okay, good. Now, once you've got that, you're going to press this 6 enough times so that 8 dice are on the screen. 2, 3, 4, 5, 6, 7, 8. Okay, so go ahead and make sure you have 8 dice on your screen. Okay, here's what we're going to do. We're going to roll these. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to roll them. Okay, so our chip number 1 rolled a 2. So you go back in your instructions, you're like, a 2. What does this mean? This means that if it rolled a 2, it goes to the right. So number 1 is going to move to the right. Okay, the second one also moves to the right. The third one moves to the right. I like my roll. The fourth one has a 5. Okay, a 5 means it stays still. Easy. The fifth one has a 2, so like a lot of moving to the right today. This one has a 5, so this is number 6, has a 5, so it's not going to move. Number 7 has a 3, which means it moves down. And number 8 has a 3, it also is going to move down. Behave yourself. What? There we go. Okay, so now at this time, go ahead and move your poker chips around to whatever your roll was. Okay, now let's take a look at our situation. My situation now, I have 3 poker chips in solid B, and I have the rest, 5 in solid A. Okay, that's not in equilibrium, right? Equilibrium is going to be what arrangement in solid A, and how many in solid A and how many in solid B would be equilibrium. Well, if I think of my poker chips as little bits of energy, like little hot dogs that are going to feed my solids or something, right? Equilibrium is when the energy is no longer flowing between the two solids. So this solid right now, A, is hotter. Oh, I hate using that term, but it has a higher temperature than solid B because it has more energy. It has more hot dogs. Okay, so this is not equilibrium yet. So what you're going to do then is you're going to go over here and you're going to roll again. And then you're going to move each one as demonstrated by the dice. Okay, so you're going to be doing this 10 times. Once you do it 10 times, then you're going to show me your final microstate here. I just put X's where I had molecules in my final 10th microstate. I'm worried that I have 9. I have like 9 molecules instead of 8. That would be a mistake. Okay, but here I go. That's why I have 8 molecules, and so I just put an X in the boxes where I had molecules in my 10th state. Now here's the thing. You want to notice, when does yours get into equilibrium? One time I did this, I got into equilibrium on the second roll. It was crazy. Other times it took me 18 rolls. It might take you more than 10. If you're not at equilibrium yet at 10, you've got to keep going, okay? And so, okay. Whew. By the way, if you don't come into equilibrium with continue to roll, you do, and then perform a few sets of rolls afterwards, because here's the thing. We need a sense of how the system behaves after equilibrium. Okay, what we're doing is we're modeling the motion of the energy in the system using random dice. So we're seeing if energy flows randomly in a system, how does the energy move? Okay, so the last thing, once you've done all of this, is how do you define equilibrium? How many sets of rolls did it take for you to get there? Describe how your quanta or poker chips behaved after you achieved equilibrium. Answers to this might include that they all went into solid B and stayed there. Solid A didn't see anything, or they stayed reasonably balanced between solid A and solid B for the rest of the time. Those are answers that you could give there. Which microstate had the greater amount of entropy, the initial one or the final one? And explain your answer. And then, based on your results, relate the spread of energy in a system to the entropy. Okay, so like in here, I would say my poker chips are pretty not spread out very much. They're really on the right, and then on the left, but anyhow, that's what spread means. One final note that I wished I had said before. When you're rolling your dice and you get, let's say if I rolled the dice for number 2, I rolled a 1. Oh, which I did here. Since number 2 can't move upwards because the wall is here, then it stays in that box. Okay, so similarly, number 5 can't go up or to the right. So if I were to roll a 1 or a 2 for number 5, it would stay still there too. Okay, I wish you all good luck with this lab, and I can't wait to see your results. Seeing everyone's final macro state is always really interesting to me, and as always, send me questions if you've got them.